In the world of commercial air travel, comfort is often a subjective term. What one person might find unpleasant about a flight, another may not. However, despite differing opinions on the quality of airplane food and the slight inconvenience of remaining in one place for several hours, most would agree that life at 35,000 feet above the ground is fairly agreeable, especially for infrequent travelers. However, let's set the discussion of comfort aside and focus on something more fundamental: survival. The primary determinant of human survival is oxygen. Whether on land or sky high in a commercial jet, regular access to oxygen is paramount to living. Therefore, it's a relief to know that airplanes ensure that we're adequately oxygenated for the duration of our journeys. You're probably familiar with the quick-drop emergency oxygen masks designed for abrupt cabin depressurization. But have you ever wondered how we breathe so effortlessly in a plane under regular conditions? We must first understand that the term breathable is significant here. It's a well-known fact that breathable air lessens in concentration the higher we ascend. However, it's not the air itself that lacks oxygen availability at such heights. The air at 35,000 feet is plentiful and consists of enough oxygen. This even applies to the altitude at which the International Space Station operates. However, the issue lies in the oxygen pressure at these altitudes. It's too low for human inhalation. Most commercial jets manage this problem using a process termed bleeding. This involves the extraction of hot, compressed air from inside the jet engines, which is then refined through a series of machines and channeled into the passenger cabin. This works by drawing fast-moving air into the jet turbine engines as the plane flies, which is then squeezed through successive layers of fan blades inside the turbine. At this compressor stage of the process, a portion of the hot air is bled off. This diverted air, known as bleed air, is initially quite hot, reaching temperatures of several hundred degrees Fahrenheit. Naturally, this air must be cooled before it's released into the passenger cabin. This cooling stage involves the bleed air expanding and being passed through a heat exchanger to achieve a comfortable, breathable temperature. Once cooled and filtered, this air is then circulated in the passenger cabin at a suitable pressure. Lastly, to sustain air quality within the cabin, an outflow valve is typically positioned at the cabin's rear to ensure that any used air is purged from the plane. Thus, the jet turbine engines affixed on a plane's side don't just keep the plane airborne by producing forward thrust, but also help regulate cabin air pressure, ensuring that we stay alert and comfortable throughout our flight.